Okay, solving trig equations. We're going to start with some really simple ones first. These examples are going to come off the worksheet that you have in front of you. We're going to kind of skip around a little bit. Okay, so we are solving, our variable here is theta. Theta is the angle. So the question here is, for what angle is the value of sine equal to -1/2? So instead of just randomly looking all over our unit circle, let's use a little bit of logic here. Sine, does that match with our x-coordinate or our y-coordinate? The y-coordinate. So if this is a negative value, which two quadrants do we need to be looking at? 3 and 4, the bottom ones, okay? So where is the y-coordinate -1/2? What angles? Give them to me in radians. Okay, so 7 pi over 6 and 11 pi over 6. Those are the two answers. You could check it in your calculator by putting it in radian mode. Which it should be, well, most of them typically are in radian mode because y'all like to reset them a lot. 7 pi over 6, okay, it gives you -1/2. Right? 11 pi over 6 will give us the same value. Okay, so that's a really simple example. Something like number 7, we need to do a little bit of work to get the trig function by itself first before we start referencing our unit circle. So right now, in front of our trig function, we've got a -3/2. So to get rid of a -3/2, we need to multiply both sides by -2/3. So that is 2 square roots of 3 over 3 is equal to the sine of theta. Now, does that look like a value we have on the unit circle anywhere? 2 square roots of 3 over 3? We have 2 square roots of 3 over 3 on the unit circle. What do we have? We got 1/2. We got square root 3 over 2. We got square root 2 over 2. We've got 0. We've got 1. We've got -1. That's about it. Okay? So let's check this really quickly. Let's see what the decimal value of 2 square roots of 3 over 3 is. Okay, that number is 1.155. Here's something you need to know about trig functions. The value of sine and cosine can never be bigger than +1 or less than -1. Just think about the unit circle. If we get all the way up to the top of the unit circle, the maximum right there is +1. We don't have any y values that get above +1. Or when we go down to the bottom, we don't have any y values that go less than -1. As far as cosine, as far right and left as we go is positive and -1. So if this is equal to something that is bigger than 1 or less than -1, this equation has no solution. Okay, this equation has no solution. You can do the 0 with the line through it, however you want to express that. But this one has no solution. Okay? Let's look at one like number 9. Okay, let's look at one like number 9. We've got -4 is equal to -3 plus the sine of pi plus 5 pi over 4. So we need to get the trig function by itself to begin with. So let's add the 3 to the other side. -4 plus 3 is -1. Whoops. All right, so where is the y value equal to -1? 3 pi over 2, okay? Well, this time that's not equal to theta. That's equal to theta plus 5 pi over 4. Theta was not the only thing inside the trig function. It had theta plus 5 pi over 4. So 3 pi over 2 is equal to this. We need to solve for the variable. So we've got one more step to solve for the variable before we're actually finished. We need to subtract 5 pi over 4 from both sides. And let's see here. That would be 6 pi over 4. 3 pi over 2 is 6 pi over 4. So 6 pi over 4 minus 5 pi over 4 is just pi over 4 equals theta. Yes, sir. Where is sine equal to -1? Okay, sine is equal to -1 at 3 pi over 2 on the unit circle. Okay, again, it's an equation. No reason not to check it. -3 plus the sine of, we said it was pi over 4, plus 5 pi over 4, whoops, over. Okay, and it does actually give us -4. Okay. So it is possible to have two solutions. It is possible to have no solution. It is possible to have one solution. Okay, there's no set number of solutions that we have with these trig equations here. All right, let's look at number 16 as well. 4 minus 1/4 cosine of theta plus pi over 3 is equal to 7 over 2. Now, please don't be tempted to put the 4 and the -1/4 together. The -1/4 is multiplied by the cosine, so you cannot combine those. We need to start by subtracting the 4. 7 halves minus 4 is what? -1/2? Because that would be 7 halves minus 8 halves. So -1/2. How do we get rid of multiplying by a -1/4? Okay, can we do it some way other than dividing? Multiply by -4. You multiply by its reciprocal. So that goes away. So we've got cosine of theta plus pi over 3 is equal to negative times negative is a positive. 1/2 times 4 is 2. Well, is there anywhere where our cosine equals 2? No. The biggest cosine can be is +1 or -1. So this is another no solution equation. Okay, cosine and sine cannot be greater than 1, so there is no solution to this equation. All right, let's look at a couple more examples. Let's look at a tangent. Okay, number 21. The square root of 3 is equal to the tangent of theta. Now, we do not have values of tangent on the unit circle, but tangent is sine over cosine. So there are only two angles. I'm focusing on the first quadrant for the moment. There are only two angles that could give us a square root of 3 in that answer, right? We've got square root of 3 over 2 and 1/2, or we have 1/2 and square root 3 over 2. Okay, pi over 4, where they're both square root 2 over 2, there's no way you're going to get a square root of 3 out of that. Okay, so the question is, which one is going to give us just the plain square root of 3? Any guesses there? When the square root of 3 over 2 is on the top, whoops, that's a 3. When the square root of 3 over 2 is the function on the top, that is going to give us just the square root of 3. So if tangent is sine over cosine, then we're looking at what Faith said, pi over 3. Okay, pi over 3. So theta is pi over 3. Now, there's another angle that would give us positive square root of 3 for sine over cosine. What quadrant would that happen in? Third quadrant, because both are negative. So pi over 3 in the third quadrant is 4 pi over 3. Okay. Alrighty, let's look at one like number 23. That looks really intimidating, but it's really not that bad. If we subtract 4 from both sides, you're gonna have to do this without a calculator, because if you try and do this with a calculator, you've got a square root involved. it's not going to put it back in nice, neat square root form. So I'm going to write this so it looks more like what's on your paper. So if I'm subtracting 4, but I got to combine it with something that has a denominator of 3, what do I actually need to subtract? 12 over 3. 12 over 3 equals 4. So we have the same denominators. We combine the numerators. Look what happens when we combine the numerators. The 12s cancel. So we want to know where the tangent equals the square root of 3 over 3. Guess what? This is the other case. It's where the 1/2 is on the top. 1 over the square root of 3, if we rationalize that, ends up being the square root of 3 over 3. So that's where the sine is 1/2 and the cosine is square root 3 over 2, which is at your pi over 6 angles. And it is positive, so we're still in the first and the third. So we've got pi over 6 and 7 pi over 6. Okay, so the tangent ones require just a little bit more work, but guess what? I've already I just did it for you, okay? Because we now know that at pi over 6, tangent is square root of 3. At pi over 3, tangent is the square root of 3. At pi over 4, what's tangent going to be? Look at your unit circle. What's sine over cosine at pi over 4? 1. It's square root 2 over 2, square root 2 over 2. So when you divide that by itself, it equals 1. And then our only other choices are at the extreme ends. It's either 0 over 1 or 1 over 0. It's either 0 or it's undefined. So me personally, I would write this on my unit circle beside pi over 3 and pi over 6. I would write which one has which tangent value. It's going to help you out in the long run. So pi over 6, tangent is square root 3 over 3. Pi over 3, tangent is just the square root of 3. Here's maybe an easy way to remember that. Pi over 3, it's just the square root of 3. Pi over 6, you got 2 3s. 2 3s added together equals 6. Just a little hint there maybe might help you out.